Okay, so in the previous video, in the previous class, what did you understand? We understood that what is a physical change, and we understood how the physical changes happen. If there is a change in shape, size, and shape, size, and color, then that is called as a physical change. Now, this paper was actually like this. It was plain white before, okay, but when I wrote on it, it became like this. So this is a physical change. Again, this is a physical change. Okay, now if I take this part of the paper, okay, if I take this part of the paper which I'm coloring and I take this part of the paper, okay, now I will test the chemicals of this part and I'll test the chemicals of this part. Then there's a chemical change because the ink is getting mixed with the paper material, and that will be a chemical change. So chemical changes happens deep within, okay, not necessarily you can see that the chemical changes are happening, but physical changes are visible to our eyes. Chemical changes are not visible to our eyes most of the time. Okay, now see here they take an example of magnesium. Magnesium is a very soft metal and it is highly reactive. Okay, so it will catch fire really fast. Okay, magnesium for burning, when you're burning that magnesium, so anything to burn we require oxygen. For burning anything, oxygen is a must. Magnesium plus oxygen will give rise to 2MgO. Okay, now this is not a balanced equation, I've told before also. Let me show you how to balance this equation. Mg usually exists like this. Mg plus O2, oxygen exists like this, gives rise to MgO. Okay, this is what we have seen. Okay, but if you see the balancing, let's do the balancing. Mg and O are the two chemicals that we have, and left hand side Mg is 1, right hand side Mg is 1. Oxygen is 2 here, oxygen is 1 here. So what we need to do, we need to balance the oxygen now. So for balancing the oxygen, I need to multiply it by 2. But where can I put the 2? I have to put the 2 here only. I cannot put a small 2 here, that will be wrong. Okay, so I have to put the 2 here itself. Okay, so I'm going to put a 2 here. As soon as I put the 2, this 2 is also implying for Mg. It also applies for O. My oxygen is balanced now very well. But my magnesium has changed now. It has become 2 magnesiums here. So I do need to make and add another magnesium here. So what I'll do, I'll multiply by 2. That means I'll put a 2 in front of this. So 2Mg plus O2 gives rise to 2MgO. This is a balanced equation of magnesium ribbon. You're going to take a magnesium ribbon and you're going to burn that ribbon. Okay, and so when you burn it, oxygen is going to get mixed with it. What is going to happen? The oxygen is going to get mixed with this magnesium ribbon. Okay, it is going to get mixed with the uh, magnesium ribbon, and then it's going to, what do you say, it's going to burn. Okay, and after burning it becomes ashes of magnesium oxide. Magnesium oxide ke ashes it becomes. Okay, now these ashes you're going to keep it aside. Now this is a chemical reaction. Magnesium combined with oxygen, these are chemicals on the basic level, and gave rise to magnesium oxide. So two things combining and giving out the third thing, that is called as a chemical reaction. Then following it, there's some more reaction that you're doing. Now, this is one part. Now what you're doing is we are taking this magnesium oxide. Okay, you're taking this magnesium oxide. You got 2 MgO, no? Here you got 2 MgO, but we are taking only 1 MgO. Okay, MgO we are taking, and with this we are adding a small amount of water. Okay, which will give rise to MgOH taken twice. This is called as magnesium oxide. It's called as magnesium oxide. This is water. This is magnesium hydroxide. Hydroxide is what we got here. Okay, now let's see if it is balanced. Before we do anything, let me just show you if it is balanced. Mg is one chemical, oxygen and hydrogen are the three chemicals in it, right? Now Mg on this side is 1, oxygen is 1 and 2, two oxygens. Hydrogen here is 2. Okay, now what about Mg here? Mg here is 1. This 2 is for this one as well as for this one. This is not I am putting now, it was already there. While we are balancing, we can put it here only. Okay, in before we cannot put here. If it is already there in the chemical formula, it doesn't matter. But we cannot add a small 2 here or 3 here. We cannot change the numbers here. We need to change the numbers in the front only for balancing. So oxygen here is 2 and hydrogen is 2. It is a balanced equation in itself. It is balanced in itself. Okay, so what did we take? That burnt magnesium ashes we took. With that we mixed it with a small amount of water, and we got magnesium hydroxide. Now, we need to check if this magnesium hydroxide MgOH that we have got, is it acidic, is it acidic in nature, or it is basic. A non-acid is called as a base. Okay, you have two types of chemicals, acid and a base. Okay, acid means, you know, which will burn things and it will be harmful and stuff. Base, it is not going to be harmful, it will not be acid, it will not burn things around and stuff like that. Okay, so now we need to check now this particular thing is acidic or basic. And how do we check if any liquid is given to you? I give you a beaker and in that there's some liquid. And how do I check if it is acid or base? So that test is done using a litmus paper. How is it done? It is done using a litmus paper. Okay, you take the litmus paper. Now the litmus papers are usually in three colors. It is yellow litmus paper. I want you to Google it and see it by yourself. Pause, Google and come back. Red litmus paper and blue litmus paper. Okay, any of these three color litmus papers I will take. I will dip it into the solution. And acid, if it is there, any litmus paper, any of these three, if I am dipping in acid, dipped in acid, that paper will be red in color. Red will remain red only, yellow will turn red. So if we write like this, litmus paper, color. Yellow litmus paper I have red litmus paper and blue litmus paper. So in acid, okay, reaction with acid, yellow will turn to red will remain red only, blue will also become red. So as soon as you dip any of the litmus papers in an acid, it will show red color. Okay, the same litmus paper, suppose I don't know what liquid this beaker is having, right? I don't know what liquid this beaker is having, I'm checking. So what I took that litmus paper, I dipped in. So now that litmus paper changed the color, maybe some color came on this one. Okay, now I need to see if it is red or blue. If it is red, though the litmus paper was also red, okay, if it is red, this liquid is an acid. If it is blue, okay, if it is blue, then this liquid is a base. Okay, it is not acidic in nature. So litmus paper again and color we have. Okay, so checking for the base now. Yellow litmus paper, be it red litmus paper or a blue litmus paper, they all will turn to blue color. All of them will turn to blue color. Okay, so this is how the thing is done. Okay, so we have MgOH, MgOH2 is there, right? This MgOH2, what we are doing, we are taking it in a beaker. Okay, there are some ashes in here. Okay, there are some ashes in here and there's a liquid in here. Okay, so what happened is, this liquid, I take the yellow litmus paper, let's take yellow litmus paper and dip in this. And if I dip that yellow litmus paper, it will turn to blue color. That yellow litmus paper turns to blue color. That means showing that this MgOH2 is a base. It is base. Base means it is not acidic. Okay, and to give you a short hint, all OH containing elements are bases. CaOH, NaOH, KOH, these are all MgOH2. These are all bases only. So any material, if they are giving an example, CaOH, okay, dipped with the litmus paper, okay, litmus paper was dipped in it, what color it will give? OH is there, oxygen and hydrogen together is called as hydroxide. What is it called as? It is called as hydroxide. This is calcium, so it becomes calcium hydroxide. It becomes this hydroxide term, when it comes, it is a base. And if it is a base, the base will turn any litmus paper into blue color. If it is a red paper, it turns to blue. Yellow paper turns to blue. Blue paper will remain blue only. Okay. So this is about your thing. Now, you are saying that the color is changing. Inside we know that the chemical reaction happened. MgO plus water, chemicals mixed and some new chemical was formed. Now, after this new chemical was formed, was this chemical acid or base? We checked with a color changing paper. That color changing technique, that color changing thing is a physical reaction which you are seeing with your own eyes only, no? That the yellow color is turning to red or blue, it is whatever. That is a physical reaction change. Okay, physical change से हम समझ रहे हैं. Understood this part?